The energy of life. How does the sun produce heat and light? To find the answer to this question, we're going to look through some of these key points. We're first going to look at the model of the sun. Then we're going to check out nuclear fusion, some solar winds, filtration, and heat and light. So, nothing is more important to life on this planet than the sun. Without the sun, the Earth would still be a huge ball of ice. The sun's responsible, for warming our oceans, for growing our plants, giving us oxygen and food, for just really life in general. So, how did it go about creating life and warming Earth? How does it make heat and light? The sun is not like Earth. Earth is actually solid. The sun is made of gas. It's just a dense ball of gas, mostly hydrogen and helium atoms. It's composed of three main layers, or three main parts: the core, the radiation zone, and the convection zone. The core makes up about 25% of the sun. The radiation zone makes up about 45%, and the convection zone makes up about 30%. Some interesting things about the sun to get just a grasp of how huge it is. About 1.3 million Earths can fit inside the sun. That's mind-boggling. The Earth is just a mere speck to the size of the sun. So, what causes all this heat and light? What is going on inside of the sun? So, the core of the sun is responsible for a reaction known as nuclear fusion. The gravity of the sun pulls its mass inwards, resulting in massive amounts of pressure, and it forces these lighter atoms to fuse together and form heavier atoms, which results in massive amounts of energy being released. More specifically, it's the fusion of hydrogen one, which hydrogen and hydrogen, tritium, deuterium, and they fuse together and they form helium atoms, and they release lots of energy, which releases lots of heat and lots of light. It's actually responsible for various kinds of light, such as infrared, UV, X-rays, microwaves, radio waves, and, of course, the visible light that we see. Not only is light released, but, heat's being released as well. The core is, of course, the hottest. That's where all the action is happening. As the energy moves throughout the radiation and the convection zone, it gets relatively cooler the further it goes out, but these zones are acting as guides. They are carrying the energy throughout the layers, and it goes out into the outer atmosphere, the corona, and eventually travels through space and reaches Earth's atmosphere. But another reason we feel heat has has to do with solar winds. Solar winds are magnetic storms that are generated within the outer atmosphere of the sun, the corona. It's an area where highly charged magnetic particles are just traveling around at really high speeds. We often see these as the aurora borealis, or the northern southern lights. If you look closely at this diagram, you can see kind of the winds coming off and how they travel around the Earth. They're not actually going through and penetrating the Earth. Our magnetic field actually pushes a large portion of them away and around, as you can see here, and only a small amount gets through to the bottom atmosphere. So a lot of the energy, is resulting in heat, but solar winds and such like that is also a factor. So, once all this energy is, these atoms collide and this energy is produced and this light's emitted and it's traveling through space, it reaches our magnetic field. I just went over about the solar winds. They get pushed over, or a small amount gets filtered through the thermosphere. So the thermosphere is, re-radiating, I believe it was, and shooting this massive amounts of, dangerous solar energy back out in space, but allowing a small amount to come through. And the other energy, is being filtered through the ozone layer. And it filters out a lot of ultraviolet radiation, but a lot of it, or not a lot of it, but some of it passes through. And a lot of that is the energy that we see as light or heat. And that has allowed the Earth to grow life and survive as it has today. It doesn't seem like a lot. Like right here it says only 1/1,000,000th of the light energy reaches the surface of the Earth out of the 230 million watts per square meter released from the nuclear fusion in the sun. So that doesn't seem like a lot, I guess, when you think about it like that, but, it's enough for us. That's how the sun gives us our light and our heat, and without it we wouldn't be alive and we wouldn't be here.